All right, forget the lab coat in the safety goggles for a minute. Today, we're putting on a kitchen apron because it turns out some of the coolest chemistry you'll ever see happens right in your own kitchen. Let's get into it. You know what I'm talking about, right? You shake up that salad dressing, it looks amazing, and then you turn around for 5 minutes and boom, it's separated back into layers. But your lemonade, it stays perfectly mixed all day long. So what's the deal? Well, that's exactly the mystery we're going to solve today. Here's the secret. Not all mixtures are created equal. In the world of chemistry, we basically sort them into two big categories. And once you get these two, you're well on your way to becoming a kitchen chemistry genius. Okay, don't let the big words scare you. They actually tell you everything you need to know. On the left, we have homogeneous. Homo is just Greek for same. This is a uniform mixture where everything is so perfectly blended you can't see the different bits. Now, on the right, you've got heterogeneous. Hetero means different. Think of a fruit salad. You can totally see the strawberries, the blueberries, all the different parts. See? The clues are right in the names. So let's try a few. A pizza or that fruit salad. Totally heterogeneous, right? You can see all the ingredients. Oil and water? The classic example of a heterogeneous mixture. But what about something like seawater or lemonade? They look like one thing, but we know they're a mix. That makes them homogeneous. Let's zoom in on those homogeneous mixtures because they have a special name, solutions. And to really understand a solution, you gotta meet the three key players. I like to call them the solution squad. First up, we've got the solvent. This is the big guy, the one that does all the dissolving. You can think of it as the main ingredient in the mix. So in chocolate milk, the milk itself is the solvent. It's the liquid that's just waiting to dissolve something. And then you've got the solute. This is the stuff that gets dissolved. So, sticking with our chocolate milk example, the chocolate powder is the solute. You add the solute into the solvent. It's that simple. So it really all boils down to this super simple equation. You take your solute, you add it to your solvent, and what you get is a solution. Chocolate powder plus milk equals a delicious solution called chocolate milk. This little formula is the powerhouse behind so many things we mix every single day. Okay, but we've all been there, right? You're stirring, and you're just left with a pile of gunk at the bottom of the glass. What do you call that stuff that just refuses to join the party? Well, that leftover solid has a fancy science name. It's called a precipitate. A precipitate is just an insoluble substance, which is a sciencey way of saying it just won't dissolve. It separates itself from the solution and kinda does its own thing. So we know what happens, but let's talk about how it happens. Let's zoom in, way in, to see what's actually going on when something does dissolve. What happens when that sugar cube just vanishes into your tea? Well, get ready, because we're heading to the molecular dance party. Okay, picture this. You drop a sugar molecule into water. The first thing that happens is the water molecules just swarm it. Then the real action starts, and it's called random molecular motion. See, all these molecules are constantly moving, bumping, and crashing into each other. It's this chaotic dance that literally starts breaking the sugar molecule apart, piece by piece, and spreading it all around until, poof, it's perfectly mixed. You've got a uniform solution. But, just like any good party, there's a capacity limit. You can't just keep cramming guests onto the dance floor forever. A solvent can't dissolve an endless amount of solute, and that limit actually helps us classify solutions even more. And here are the three levels. First, you have an unsaturated solution. This is like a party with plenty of room on the dance floor. You can definitely dissolve more stuff in there. Then, you have a saturated solution. The dance floor is officially full. It's holding the absolute maximum amount of solute it can handle. And then, you have the wild one, the supersaturated solution. This is when the party is way over capacity, usually because you cranked up the heat to sneak more guests in. It's really unstable, but it's holding way more solute than it should. All right, now that we're armed with all this chemistry knowledge, let's head back to the kitchen and figure out those weird mixtures from the beginning. I'm talking about things like milk and salad dressing that don't quite play by the normal solution rules. So first, let's talk about the colloid. The colloid is kind of a cool in-betweener. It looks smooth and homogeneous, like a solution. But if you looked up close, you'd see its particles are actually way bigger. Milk is the perfect example. It looks uniform, but it's really just larger blobs of fat and protein floating around in water. They're distributed evenly, but they aren't truly dissolved. And colloids are absolutely everywhere. You've got four main types. A sol is solid particles in a liquid. Think muddy water. An emulsion is when you mix two liquids, like the oil and vinegar in salad dressing. A foam is just gas trapped in a liquid, like the foam from your soap. And an aerosol is tiny little particles floating in a gas, like from a spray can. Now, those colloids, they're pretty stable. They tend to stay mixed. But there is one last type of mixture we need to talk about. This is the one that only works if you give it a little encouragement. You know, with some shaking.
And that brings us to the suspension. This is it. This is the answer to our salad dressing mystery. A suspension is a mixture that looks uniform only when you shake it or stir it. The second you leave it alone, the parts start to separate all over again. Your salad dressing is the poster child for a kitchen suspension.
So let's break it down one last time. The big difference between a solution, a colloid, and a suspension really comes down to two things: how big the particles are and whether it separates on its own. Solutions have tiny molecular-sized particles, and they never separate. Colloids have medium particles, and they don't separate either, but suspensions, they have large particles that will always separate if you just let them sit. And that brings us full circle. The next time you're in your kitchen and you grab that bottle of dressing and give it a good shake, you'll know exactly what you're doing. You're not just making a salad, you're creating a temporary suspension with the power of chemistry. How cool is that?